Here I am going over the review problems we did in class. We have spent several weeks working on factoring. So we took one day where we could step back and review all of the different factoring types in one day. This is a very important part of our curriculum this semester. We will be using it for everything we do next, and you'll see it a lot in your future classes. And before we get to this worksheet, so this is a worksheet I handed out in class. There are 9 problems here, so we have 8 on the first page, and there's one more on the back. I want to briefly go over the factoring guide that I had given you. It could be on some color paper, purple, blue, something like that. So we worked on 5 kinds of factoring. The very first kind was greatest common factor, or GCF, where we find out what's common and we divide it out. What's common could be a monomial, like 2x squared. And this one, what's common is a binomial. And then if our factoring problem starts with a negative, like this one does, we have to use a negative GCF. We learned about trinomials. So 3 terms. They factor back to 2 sets of parentheses. And we do have what I called the easier ones and the hard ones. So easier trinomials don't have a number at the beginning. And we can just set up the parentheses and get our product and that we need to work out in the middle. The harder ones have the number at the beginning that we cannot divide out as a greatest common factor. There are 2 ways of doing those. The grouping or AC method, which is the way I taught you, but you could also do trial and error, and I'll talk about that briefly when I go over one of the questions. We did difference of 2 squares. The abbreviation for that is dots. DOTS. That's for 2 terms. So if we have something like x squared minus 16, it's simply the x plus 4, x minus 4. And then reminder that x squared plus 16 does not factor. It's called the sum of 2 squares, so it's not the difference of 2 squares. If you try x plus 4, you're going to get plus 4x, which will give you plus 8x in the middle, and there's no middle term here. So you need the plus minus in there to give you the minus for there to be no middle term. We also learned factor by grouping, which you use with 4 terms. That's where I visually then to draw a separator, and you do the greatest common factor on each pair. You should end up with a common binomial when you do this method. So the x minus 2 is common. And you factor that out, and you're left with a 5x squared minus 3. And the last type of factoring problem we learned was called the sum or difference of 2 cubes. And this is the only one on here where you truly need to use a formula. And the formulas are listed here. I'll be going over one of these examples in the review sheet. On the back side of the factoring guide is more of a flow chart. This is how it is helpful to think about approaching a factoring problem. You always want to look for what is common first. After that, it depends on how many terms you have. If you only have 2 terms, it's either going to be a difference of 2 squares or the one with the cubes, which we need to use the formula. If you have 3 terms, it's a trinomial, and we would have easier ones and hard ones. 4 terms means grouping. We split it into 2 groups, and we do the GCF in each group. I'm just going to go through these in order. They are all mixed up, the different factoring types. So the first one, it's a trinomial, but we do have something common in here. So we have all those numbers are even, so we can divide them by 2, and we do have x and everything. So the GCF first Now this starts with a negative, so we need to use a -2 and just the x because we choose the lower common exponent there. So take out the -2x. We're dividing everything by a negative, which is going to change all the signs of these. So -2 divided by -2 is 1, but we have x to the fifth. We took out an x, so we have positive x to the fourth left. 28 divided by -2 is -14. X to the third divided by x. We go down one exponent, so we're x to the second. And then 64 divided by -2 is -32. And the x that we had, we divided out. So that is step one. Now, I have up here that the directions are to factor completely. Most of these problems are going to need more than one step. So once we do that GCF, we're looking to continue. In here, we have a trinomial, and it's considered an easy trinomial because you don't have a number in here. So we're just going to let this GCF hang out. This factors with x to the fourth. We break it up as x squared times x squared. And then what multiplies to 32 but gives us 14? So you could try 8 times 4, but that won't combine to 14. So 16 times 2 would work there. And we need -16, +2 to get a negative on the end, but have the -16 plus 2 combined to -14. And bring down your GCF. Now we want to look at these two answers and see if we could factor further. They're both binomials. This one is considered a difference of two squares. So this one will become two more parentheses, x times x, and then +4 -4. This part is prime. It does not factor again because it is not the difference of two squares. And bring down your GCF. So this was a three-step factoring problem. As long as you have all three of these parentheses, it doesn't matter what order you put them in. So number 2, another trinomial. Look to see if there's anything common. Can't divide any number. C is not in everything. D is not in everything. So this is one of the harder trinomials because we have a number at the beginning. But what method I taught you is called that AC method, where you multiply the first coefficient times the last one. So 9 times 14, well, -14. And we did this x here. So 9 times -14 is -126. And we want to get a sum of -15. So we're trying to get something that works out to be -15. We're looking for two numbers that multiply to here, but add to here. So when you get these large numbers like that, just start dividing it by 2, 3, 4, work your way up. 126 divided by 2 is pretty large. We're looking for something that would give 15. So 126 divided by 3. 3 and 42 could not give us a 15. So this is our product that we're trying to get. And this is the sum we're trying to get. So 126 divided by 4. Doesn't divide evenly, so we skip that. We can't divide by 5. So 126 divided by 6. 6 and 21. They could give us 15. So they need to be different to multiply to a negative up here. And we would need our negative on the 21 and a positive here. And you can put that in your calculator. 6 minus 21. Verify that you get what you need. So what we do is we split this middle apart. You keep the 9c squared at the beginning. And if one of these is negative, I like to use that as my first term when I split this. And this has CD with it, So we're going to use CD on these. So minus 21 CD plus 6 CD minus 14 D squared. I like to put the negative first because then I don't have to deal with a negative GCF on the right side. So now we have 4 terms and we're going to do factor by grouping. So we have what 3C common over here. So I'm going to leave it with 3C minus 7D. On this side, we have a plus 2D. And whatever the sign is here is what you want to bring down here. So 3C minus 7D. And when you do factor by grouping at this point, we're looking for these to match, which they do. So that is one of your factors, 3C minus 7D. And the other one is when you take those out of there, you have 3C plus 2D. And you can multiply this all out and verify that you get back to the original. Number 3, fundamentally, it's a 2-term question. So it either is going to be a difference of squares or one of those cubes problems. You've got a 36 and a 49 in there. So eventually it's going to be something to do with the difference of squares. But we have y to the 5th and we have y. So we want to do GCF first of y. So that brings our exponents down by 1. 36y to the 4th minus 49. Now we have a difference of 2 squares. Those are the ones that just factor back to 2 parentheses. And we use 6 times 6 or 36. And because it's y to the 4th, we use y squared, y squared. So that gives us 36y to the 4th. For 49, you want to use plus 7 minus 7. And then we have the GCF there of y. And in terms of looking at these 2 answers, neither one of these are difference of squares again. So we are done. Number 4, factor using a GCF. Now, this looks like something you might want to multiply out. But because we're factoring, our goal is to get things back in parenthesis form. So if we multiply this out, we're going to have no parentheses at all, and we're going to have to work even harder to factor it. So do not multiply out. Okay. What we want to see here is that 5x minus 1 is common. So a binomial, GCF on this one, 5x minus 1, but it's to the power of 2 in both of these terms. So our GCF is to the second. So we are going to take 5x minus 1 to the second out. We're dividing it. We're taking it away from both of those. You're left with 7a plus 6. That's how short that problem is. And our answer is in parenthesis form, all factored. Number 5. 2 terms. You got a 16 in there, which is a perfect square, and you have to the power 4 here, power 4 there. So there's no GCF here, but it's simply straight up, it's a difference of 2 squares problem. So difference of 2 squares is automatically 2 parentheses, 4 times 4, and then a squared times a squared, 4a squared, 4a squared. Plus minus for the negative, and then b squared, b squared. Now we still have binomials here with squares in them. So we're looking to see if we could factor again. This one here is called the difference of two squares again. So we could factor that again. This one is the sum of two squares, which remember on the factoring guide, just pull that back up, something like x squared plus 16 won't factor again. So this part's prime. So just bring that one down. And then this becomes two sets. 2a, 2a, plus minus for that, and then b times b. And again, as long as you have all three of these, it does not matter what order they are in. All right, so number 6. It has 4 terms. So this is grouping method. And we want to see if there's a common factor first. No number would work. And there's no variable in everything. So there's no GCF at the beginning. So let's split it up. We have 5 and x squared common on the left side. So that will leave you with y plus 2. So we should anticipate that we get y plus 2 over here when we do a GCF. So you could put this like that, y plus 2, and work yourself backwards. What do you need here? It would have to be -7. But this half, it starts with a negative, so that sign always comes down for your GCF, and 7 is what's common. And when you divide them both by a negative, it changes both signs to positives. So we have our common binomial. So y plus 2, and then 5x squared minus 7. Number 7 has some pretty large numbers in it. Y to the third here. There's no y out at the end. So because it's y to the third and there's no GCF to bring it down to something smaller like y to the second, it's going to have to be a cubes problem, which is the one with the formula. Now we're looking to have perfect cube numbers in our problem, and I want to remind you on your calculator there's a key like this, or you may have a key that has a 3 in there, which is cube root. If you're not sure if these are perfect cube numbers, put it in and see. So on this calculator, the key is right here in between the pi and the caret. You have to hit the 3 first, which means I'm going to do a third root question and put the 54 in there. So 54 is not a perfect cube. You could do the same for 250. That isn't either. These are both even numbers. So in terms of a GCF, I know I could do a 2. So if you do 54 divided by 2, we get 27. You should recognize that as being a perfect cube. So we are going to do GCF first of 2, 27y to the third plus 125. So 27 for a cube root. If you don't know how to get that, you bring up your cube root key, put 27 in. It breaks down to be 3. And then 125. So 3, hit the second key, bring up your root. 125 breaks down to 5. Those are the pieces you're going to use for your formula. So let's first get this written as cubes. We're going to let the 2 just hang out as a GCF. This is going to become 3y to the third plus 5 to the third. And I'm going to write the formula down at the bottom. This is a sum of 2 cubes. So a cubed plus b cubed. it's going to be A plus B, a binomial, and then you're going to have a trinomial for your other answer. So you square the first part, so A squared. Product of these two in the middle, and the sign here is the opposite of what we put here, so it's a minus. And then you square the second part here and the end here, so B squared. So it's square, product of these two, and then the square of that one. So this formula and the other one is on the bottom of this factoring guide. The formulas are the same in terms of the variables, and I just talked about, to remember the signs, it's called SOAP. Same, opposite, always positive. So the same sign, your first factor is the same sign as the original. The next sign over here in your trinomial is the opposite of the original. The last sign's always positive. So the first factor is this is your A, and that's your B. So 3y plus 5. And then, so this is the only factoring problem type where we get a binomial for one part and a trinomial for the other. So we're going to square what's here, both parts, 9y squared. Next sign's the opposite of what we have here. Then the middle part is the product of these two. So 5 times 3 is 15y. The last sign's always positive, and then you square what you have here, so 25. And then we had that original GCF of 2. So that is the answer. All right, number 8. We've got a trinomial. Look to see if there's something common. The only thing you could divide into 21 are 3 and 7, but they won't go into the 32. There's no variable in everything, so there's no GCF. So this is one of the harder trinomials, where we are going to first multiply these two together. So 12 times 21 is 252. And we're going to get positive because we have a positive times a positive. So we are trying to get two numbers that multiply to 252, but add to this middle number, minus 32. So 252 is a pretty large number. As I said before, you can start by dividing by 2, 3, 4, and work your way up. Let's just see what we get when we divide by 4 and see if we're anywhere close to getting a 32. So 252 divided by 4. 4 and 63. They are really far apart to get this. We can't divide it by 5. So I just say go by maybe even numbers, 6, 8, 10, 12. So let me skip the 6 and we'll go to 8 and see if we get anything. 8 doesn't divide evenly. We can't divide it by 10. So let's go to 12. 12 and 21. You might want to just make a note. 12 times 21. Could I get a 32 out of those? You could. I'm going to do this in pencil because I know what happens, but let's put 12 and 21 here. Oh, see, I was thinking visually that could be 32, but it's going to be a 33. So they are not right. They look like they might work, but they don't. So 12 and 21 don't work. So let's do 252 divided by 14. 14 and 18. We need to multiply to a positive, so signs have to be the same, but add to a negative. So we need them to be negative, negative. And then you could check negative 14. Okay, on a calculator, negative 14 plus negative 18. So that's negative 14 plus negative 18, negative 32. So when you have the large numbers, it does take a little bit extra time to find out what pair you need. So we're going to split the middle. 12x squared, and they're both negative, so it doesn't matter where I'm going to have to deal with a negative GCF on that right half either way. So factor by grouping, we got 2x common here, so 6x minus 7. Now the right half starts with a negative, so it's going to be a negative GCF, and 3 is what we can do there. So negative 18 divided by negative 3 gives you that 6 that you need to match here. 21 divided by negative 3 is negative 7. And you have your matching binomial. This time I'll write it second, just so you understand that it doesn't matter what order you put your two binomials in. So the other part is 2x minus 3. So I do want to just briefly talk about trial and error, if this is something you recall doing. You would take your choices for the first number, which are 12, all the ways you can multiply to 12. 1 times 12, 2 times 6, 3 times 4. And then you would take your choices for 21. 1 times 21, 3 times 7. You would start with your two parentheses right here. You wouldn't do all this in the middle. You would just start picking with choices for the 12, like maybe start with 3x times 4x here, and then start with 3 times 7 here. Play around with it, see if it works out. If it doesn't, then you got to do the 3 and 4 with the 1 and the 21. If that doesn't work, then at the front you use 2 and 6 with 3 and 7. So you got to play around with it, but you can get the answer that way. So here we go. We're ready for the very last question in here. This factoring review is perfect to help you study for the test we have that will be coming up. They're a great group of questions, and you'll have something like all of these on the exam. So you could write these down on an index card and put the solution on the back and just practice them. Last one. So factor using substitution. Now it has some parentheses in it already. And back in our first unit, this would be something we might want to multiply out to simplify. If it said simplify, we'd multiply it out. But we are trying to factor, so we do not multiply this out. The parentheses are there to help us get the problem started. And I do want to compare this problem to one that we had earlier. Let's look at number 4. On number 4, the binomial that we had was common because we only had 2 terms. This one this is one term, a second term, and a third term. So this is what I said, it's a trinomial in disguise. (11x plus 7) is not common out here a third time. So there's no GCF on this one in terms of a binomial. And so the substitution means that what we're going to do is we're going to take this 11x plus 7 that is somewhat common to 2 parts, and we're going to choose another letter for it other than x. In math, we usually use u, but you could use whatever letter you want. So this is going to be a u here and a u there. So this gets rewritten as u squared minus 6u plus 5. And there's something familiar we're used to factoring. It's an easy trinomial. So these are the ones without a number here that you don't have to do the whole AC and grouping method. You can if you want, but you'll just end up with the u times u at the beginning, and what multiplies to 5, but we'll add to 6. So that the only choice here is 5 times 1 minus minus to get positive there, and then here's your minus 5 minus 1 combines to minus 6. Now we're not done. And when we factor, we need our final answer to be in the same variable as the original was. So now we need to resubstitute 11x plus 7 back in for u. So this part and that part. Okay? So u actually represents 11x plus 7. And then bring down the minus 5. And then 11x plus 7 and bring down the minus 1. And now just clean up each inside part. So combine like terms. 11x, 7 minus 5 is plus 2. And then here, 11x, 7 minus 1 is plus 6. So we get a normal looking answer for what a trinomial would factor to. So our final answer is in terms of x. So this is what we did in class. And there is a homework sheet that goes along with this. So if you weren't in class, you could look for that to be posted online or email me about it.